Insolation, breaking it down, insolation means incoming solar radiation. So that's the energy that we receive from the sun. This is going to tie back into your astronomy. Remember, I told you everything here this year ties together. So if I'm looking at radiation and temperature, as the temperature increases, so does the ability of that object to radiate or give off heat. The more you absorb, so the higher your temperatures, the more you can radiate. Also, you're going to radiate at a longer wavelength than you were absorbing. What we just mentioned about visible light and then getting absorbed and re-radiated as infrared. Intensity is the rate at which energy is being transferred. My unit, joules per second. The greater the intensity, my higher my temperature. Now, my intensity is going to be greatest when that sun or my heat source is directly above me, so at a 90-degree angle. Because what you're doing is you're concentrating that energy just right below you. The lower my angle, I'm dispersing that same amount of energy over a larger surface area. So it's less concentrated, it gets diluted. So remember, it's most intense directly above, lower angle, less intense, it gets diluted. So we need to look at factors that are going to affect my angle of insolation. Like I said, this is your astronomy. So I'm looking at my angle if I look at seasons. During the wintertime, if we have our lowest angle of insolation. So that means we have our lowest intensity. Summertime, we have our highest angle. Now, it's not directly overhead of us. Remember, the only state that has the sun as the zenith, Hawaii. But it's going to be, for us, June 21st, around 71 degrees from the horizon. So that one's going to be when we have our greatest intensity. Obviously, our equinoxes are in the middle. So you're looking around, for us here in Central New York, around an angle of 48 from the horizon. Latitude. Back to astronomy. December 21st, most intense. The sun is directly overhead, or the zenith for the Tropic of Capricorn, which is 23.5 degrees south latitude. On your equinoxes, be it March 20th or 21st, or September 22nd, 23rd, most intense, the sun is the zenith for the equator. June 21st, most intense, Tropic of Cancer, which is 23.5 degrees south latitude. That's where the sun is the zenith on that date. Duration of insolation. Now, going back to that one diagram that we had with astronomy, it had the celestial sphere. The higher the angle, the larger the arc. The larger the arc, the longer you had, or the more daylight you had. The more daylight you have, you're going to have a greater intensity for your solar noon. It's higher in the sky. So for us, it's highest in the sky, June 21st, solar noon. Lowest in the sky is going to be my sunset and my sunrise, just as the sun is coming to the horizon. So a time of day, most intense solar noon, least intense sunrise, sunset, lowest in the sky. Shape of the Earth. Because of the shape of the Earth, we get that curvature. There's only one latitude that can have the sun as a zenith per day. So with that one, we talked it's oscillating between 23.5 degrees south latitude on December 21st to 23.5 degrees north latitude on June 21st. So in between those, it's where it's going to have the most intensity for each particular day of the year. Alright, so we're looking at temperature and insolation. Remember, insolation, incoming solar radiation, the energy coming from the sun. So if I look at the summertime we have the greatest duration as you notice, the sun is rising around 5 o'clock in the morning. It's up, if you're up, and you're setting around 9 o'clock at night. So I got my longest amount of daylight. It's my highest angle, so it's my greatest intensity. All right, with that combination, it gives the Earth more time in the northern hemisphere to our southern hemisphere, because right now it'll be our summer soon. It'll be their winter soon. All right, it gives us more time to absorb that visible light. The more energy or visible light you absorb, the more you can radiate as infrared. The more you radiate as infrared, the higher your temperature is. All right, so let's think about if I'm not considering cloud cover, wind, or if it's a cold front, warm front going through, those little variables. If I go with it's a cloudless night, no fronts going in, my coolest time of the day is right before sunrise. And that is because all night long you've been radiating, or you've been giving off that heat you absorb during the day. So as you radiate, your temperature drops. The warmest time of day, a lot of people think it's solar noon because it's got the highest intensity. Not true, because remember, all night long you've been radiating off heat, you've been giving it off. You get that lag time because now you got to reabsorb heat energy. All right, so it's not going to be solar noon when it's most intense. It's actually usually mid-afternoon. So the whole idea is you keep absorbing until the sun is setting. So with that one, my warmest time of day, mid-afternoon. Now mid-afternoon on the clock is going to vary with your seasons. Because remember, your sun is going to set around 9 o'clock in June, but around 4:30 in December. So mid-afternoon is going to vary time-wise. So for today's high temperature is supposed to be 89 degrees, and that's supposed to be at 5 o'clock in the afternoon. You've been absorbing through solar noon, even into like later in the afternoon. You hit your high, and as the angle decreases, you have less intensity, so you're not absorbing as much. You're starting to radiate a little less, a little more. You're radiating more. Clouds at night, I already talked about this one. Keep us warmer. Clouds during the day, keep heat out. It's going to keep us a little cooler. All right, you need to go, how is actually air heated? Here's the sun. The sun radiates heat energy. That actually gets absorbed by the ground or buildings or whatever is out there, trees. Remember, majority of the radiation reaching the Earth is visible light. That thing gets re-radiated as infrared. It's going to heat up molecule by molecule, or conduction, the air above it. Once the air above it is warmer than, well, once the air above the land is warmer than the air above the air up here, you're unstable. So the lower atmosphere is less dense than the upper atmosphere there. So you get that convection current, because the less dense gets pushed upwards by the cooler, more dense air. Remember, as you leave your heat source, you start cooling down, you become more dense, and you're going to sink. So it all comes back from radiation of the sun. The sun is our major source of energy. Heats us up, heats the Earth up, surfaces. That gets re-radiated as infrared, molecule by molecule through conduction. All right, the warmer air is below the cooler air, unstable, so that's going to cause convection currents to happen. So we're back to your conduction, convection, and radiation. Okay, let's do a little 8th grade review. Really important that you remember this one, because this is going to tie into meteorology. Temperature and pressure are inversely related. Well, what's inversely mean? So inversely means opposite. So as the temperature increases, the pressure is going to decrease. As the temperature decreases, the pressure is going to increase. So what one variable does, the other does the opposite. So that's what inversely related. Also important for you to know, winds blow from high to low pressure, high energy to low energy, all right? So blowing from high pressure to low pressure, this, like I said, it's going to tie back to your meteorology. Or forward to your meteorology, I should say. This is your foundation. All right, we need to talk sea breeze and land breeze. I need you going back. It's during the day, the sun is out, here's my land, here's my water. Which one heats up faster? Well, it's the land, because it has a lower specific heat. So this one's going to be warmer. And this one's going to be cooler. We just talked about how temperature and pressure are inversely related. So if it's a warmer temperature, it's going to have a lower pressure. And if it was a cooler temperature, it would have a higher pressure. So also just noted, winds blow from high pressure to low pressure. So my wind is going to blow from the water towards the land during the day. That's what a sea breeze is. All right? Cooler, warmer during the day, because it has a higher specific heat, takes longer to heat up. So it's got a higher pressure. So sea breeze. During the night, I'll put a full moon for you, peaking at midnight. So with that one, it's my land breeze. Land has lower specific heat, so it will radiate off heat quicker. So during the night, this is going to cool down above the land. The water having a higher specific heat takes more energy and time to lose that heat. So that's actually going to retain its retain its temperature. So it's going to be warmer at night. Again, remember, temperature and pressure are inversely related. Cooler land is going to have a higher pressure. Warmer water is going to have a lower pressure. Winds blow from high pressure to low pressure or from the land to the water. That's known as a land breeze. That's at night. Remember, this one, lower specific heat, loses heat quicker than the water. So the air above it's going to get cooler than the air above the water. Temperature and pressure inversely related. Winds blow from high pressure to low pressure. Land breeze. All right, hopefully you remember all this because like I said, it's all going to intertie. As you saw, some of your astronomy came back and this is going to tie into your meteorology, which is your very last topic. All right, good luck. Hopefully I see you at Google Meet.